Welcome to Driven. I'm your host, Paul Perrone. We're going to learn and talk about AI, robotics, autonomous vehicles, and so much more. Check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. So kick back or buckle up and become driven. Robin, thank you so much for agreeing to do this today. I really, very much appreciate it.
And it's great to be here. Thank you.
Thank you. You may not know this, but you inspired my own personal robotics trajectory and career. I read your introduction to AI robotics book, probably your first edition, but then we had the chance. And you probably don't remember this, to meet at this conference that I don't think exists anymore called CeBIT in Las Vegas. It was in 2004, 20 years ago. So, and I got to listen to your presentation on disaster robotics, and at that time, some of your work with the World Trade Center effort. And I found that, of course, immensely fascinating, and to learn more about your work in human-robot interaction. You're the Raytheon Professor of Computer Science and Engineering at Texas A&M, and we have some deployments sort of in Houston and in Austin. So when I'm coming that way, I'm going to see if we have a chance to meet for coffee. And then I was really fascinated to hear about your or also learn about your book, Robotics Through Science Fiction, and I want to talk a little bit about that today, because that's, of course, very interesting to a lot of us who were inspired by science fiction to even get into the space that we're in. So I don't know if there's anything. I don't know if I've done justice to you've done a lot in your career. So if you would care to kind of highlight some things that might be interesting to our listeners.
Well, thank you. And what a great introduction. But first, let's be very clear. I'm one of many people who work in disaster robotics. I was part of the team that was there at the World Trade Center, which was the first use of robots for the rescue phase. And these small developmental robots, that team was led by John Blitch, one of my former grad students, and a group of other people from industry and even the military around there. So it's not just me. But what happened after that was it was very clear that this was an inflection point, that there was just another group in Japan, and our group had been looking at robots for disasters, and if we were, and they were proven to work, but there's no institutional pressure to keep. So I just took it upon myself, with a big family council with my family, to go out and basically become a professor in the classic professor sense, proselytizing, going to lots and lots of talks, trying to drum up, look, it's ready, it's not perfect, good enough, need to do more, you need to be investing in it, you need to build it, here's how you tweak it, here's what you do, here's where the AI comes in, here's we should be training. And so that's really what I've been doing since then.
It's such a great application, of course, for robotics. Maybe in many ways the perfect application, I guess. But just kind of going back to maybe the beginning a little bit too, before we get to how you got to there. What sparked your interest in robotics and AI to begin with?
I wasn't terribly interested in robotics coming up through the ranks. I was expecting, I guess I'm a highliner, right? The very first, not a C. Dick and Jane McGuffey reader book I read, I snuck in and read my dad's copy of The Green Hills of Earth. The very first story is about a woman who is an electrical engineer on a space station. And given the guy's grief, because they were kind of like, oh, we can't have women in the space station. It's like, look, no. And just that. And so I just always grew up with that expectation of being an engineer. And so I didn't really think about robots as much. Then I got into graduate school. After I worked in industry, I was in graduate school in computer science, and I was in this terrible choice. I had this wonderful scholarship, but the deal was I had to work for a professor in our department who was part of this program in computer integrated manufacturing. Well, one of the professors that I knew and I had worked with before, really smart, really talented, really theoretical, really old, just kind of shuffling down the hall. So I was just like, oh God, no. But we had this new guy, and he was doing computer integrated manufacturing from the state of robotics. He was talking about artificially intelligent and robotics. And I thought, well, that's two bullshit things, artificial intelligence and robotics. But he's not him. So let's go with the one I don't know. And then 2 months later, I was just totally in love with artificial intelligence, the cognitive science side, how it ties into how we think, how animals think, how we look at the ecology, how to design robots with intelligence, all of that, and never looked back. But it was a complete surprise to me and to my husband as well.
And were neural net, which I know a lot of people today, and we'll talk, always think neural networks when they think of AI because of it's been such a deep learning, and but AI has a much broader um, scope of application, as you know. But I guess were neural networks really kind of uh, like a thing at all, sort of when you first got into this, or is this something that sort of just came along over time? And
You're making me feel very, very old, Paul. I
I,
was there.
I'm with you.
I was there when they were starting them and the connection systems with Rumelhart and McClellan's work and all these different things. And we looked at them and the Perceptricon and all those things, and they didn't work, right? And so, and then I was coming out right in the big AI winter. But we tried that. And so some of the fun things that I love about my students now is like they want to use machine learning for everything. Machine learning, great, love it. But it's not, there's one of the neat things about robotics is it's not a one size fits all. There's not
Right.
one robot that's perfect for everything. There's not one algorithm, technique, or approach that's it. So what you want to do is learn how to paint. And you need to have the blues and the yellows and the reds. You need to mix colors and you need to understand the subtleties of black and white and all of these things and there. And so the same thing with neural nets. So come up and it's like, yeah, I've heard this. I actually think I said in my lecture yesterday to my robotics class, yeah, that's the third pass we've had at trying to solve this with neural nets. Maybe this time. Uh, so I like to think of it though. I heard somebody gave a great talk and they referred to the breakthroughs that we're getting now, even though we're getting, I love Gary Marcus. It's kind of like, yeah, we get the breakthroughs, but we're kind of hitting the plateau. You can only do so much, keep, incremental improvements. You're not going to get the big change that we see. But it's more like compilers. Really important. The moment you get one that hit computer science, it was like, whoa, yay. Now it's just something you do, but you wouldn't think compilers as a be all and end all. It's just, yeah, it's something we do. We got it. Good job.
Right. And it draws so much attention, deep learning and neural networks. But for some robotics applications, especially autonomous vehicles and determinism and knowing what's going to happen is pretty important.
And there's different levels of that determinism and predictability, right? So it's not just that we think of the determinism in like the sense of path planning, or which algorithm is going to execute with the rate update rates. Some of that's hard. Some of the veracity of these methods. When does computer vision break? So getting over a little bit to science fiction, I recently did an article on Zed, a book that came out that's pretty funny. It's kind of like a catch-22 kind of event for science robotics, and it goes something like this: you have imagine a near future, a guy has committed murder, a big, Ed drone from RoboCop that's been repurposed for the military that's not supposed to shoot somehow goes in and the bad guy gets up and leaves and another pensioner sits down, has a cup of tea in his paper, and the robot shoots and kills him. So what's the right response? The right response is for the company to say it's the victim's fault for not being being a place that somebody else was predicted to be. It's all their fault. And the government needs to give them more access to more data so they can improve their algorithms. And that was, sort of to a certain degree, sums up what I see some of the challenges that we have right now with the deep learning and the large language models and the neural nets approaches that we're getting. It's like, well, we just can model everything.
Yeah, I mean, and then when something does go wrong, how do you describe why it went wrong when you're looking at a bunch of numbers and weights, right? It's
Well,
just
in the book, it was so funny. So eventually, one person is very tenacious, and finally, they're showing the diagrams, which she described of, oh, we've traced out the path, and she's like, yeah, this to herself saying, yeah, this looks like a kitten who's batted around a ball of string. I mean, there's no figuring this out. And then you're hearing the interior monologue of the scientists, and they also haven't figured it out, but they're just, hey, look, this is our idea of transparency. We show you this trace that we can't interpret ourselves, but we're not telling you that part. And then they get into this whole thing that she eventually discovers that what happened was there was a blinding. The sensors were blinded by a sudden shaft of light because it's always rainy in that area of Britain, and then it's sunny. Didn't know how to react. Didn't have any safeguards to say, oh, that's different. Pause. And then she looks over at the guys and they're explaining how they've developed it with VR glasses. And she realized, well, of course they would forget that if it's an outdoor robot, that there's going to be outdoor things like the sun goes in and out and it gets shadowy because they've never been outside in their life. They're just sitting in their VR or then going to their house, going home and working remotely and not seeing people in real life. So it was very funny the way they said it. I think I probably ruined the book for everybody, but it's a
no.
clever book.
What is the name of that book again?
Zed.
Zed. Yeah. I usually put up pictures of books referenced and stuff like that. That is interesting because so many things you just mentioned there. I mean, it makes me quiver a little bit because it's so reminiscent of what happens on a day to day, or well, not day to day, but month to month basis when you're trying to unpack, an issue. Like what went wrong? How do we figure, like, and then you find out it's something really, subtle that, after a lot of investigation that that you now becomes part of your QA test methodology, and then you have to maybe even redesign for because you didn't consider so many things that happened with ground-based robotics, that just given the complexity of our environment that you have to consider. Not to
I,
mention the fact that might have been on in a different planet. I don't know that book.
it's a near future. It's a near future.
Okay.
Makes it
Okay.
more funny, because there's a lot of tech bros stuff in there, and the bazillionaire who is controlling everything. So it's a social satire as well. But I think one of the things bridging from the book to your comment about ground robots, there's never been a lot of money in ground robots. There has been in the autonomous vehicles, right? But in terms of ground robotics, and we've seen a big investment in drones, but we haven't seen as much. And I think that's allowed us, like in some industries, you have to worry about whether decisions are being sort of influenced by financial incentives. And I hope we can stay out of that in robotics and keep focused on the engineering and science issues.
Yeah. What any thoughts on why there hasn't been as much funding on ground robotics?
Well, the applications, have to, something, let's look at the Roomba. It
Hmm.
had to be very, very cheap, and it had to find, it's hard to develop a generalized robot. So you're picking an application that you can build something cheaply and make money at. So, you have to be very clever. Warehousing, that turned out the Kiva robots that became Amazon. All of a sudden, one day realized, why are we letting them license? Just buy them. This is our, our competitive advantage or
Yeah.
superpower. It's this type of these little turtle robots. So I think you could see there where you get some big money. But things like search and rescue, it's a low volume, low profit market, and it doesn't have a centralized purchasing agency. I mean, you get all these military groups who come over, and they then when they start realizing not only is it low volume and low profit, that they have to go to each state and municipality to sell to them. That there may be a list that FEMA will give, like our Department of Justice will give, but it's not the same thing as the Department of Defense saying, okay, we're doing this as a program of record in buying, 50 million here and 75 million of these and stuff like that, every couple of years. And so there's no money.
Yeah. Yeah. And I guess with certainly the larger the vehicle, the larger the platform, the more room for carving out a piece of the economics to make it practical for, of course, a large truck or a large, bus, or in the case of aerial vehicles, that they can, depending on, they can become pretty expensive
Yeah.
for especially the military and so yeah, I guess that the consumer, more commodity oriented applications struggle in that. And I guess, I've wondered, are there going to be things in robotics that make making robots more economical? More like, is 3D printing going to revolutionize or help lower the cost of manufacturing, or we're going to see a breakthrough in battery technology, or where there can be a lot of expense?
We've seen a lot of both, right? 3D printing and batteries and stuff. I tell people to think of drones and a lot of the smaller robots when I give training classes for responders. Think of think of your robot and look at it the way you'd buy a printer. You realize the printer's cheap, but they get you on the ink.
Yeah.
And and one of the nice things about the DJI series, I know they're not, all that, but they were inexpensive and the batteries weren't expensive. They had that large scale of production and consumer goods. You could get it. Now we get very specialized robots and the batteries are twice as expensive and they don't last as long. So you're
Yeah.
going through them pretty fast. So it's like the difference that printer ink, just like really. So you have to keep in mind that.
Yeah, and they give you the starter batteries, which is the equivalent of the starter ink cartridges too, which will only last you a few hours with all of these devices. So I guess, so getting from your sort of how you got into robotics and AI to disaster robotics, which we've just been talking about, like what drew you into that space? If there was a moment or just a sequence of events?
Well, there was, and it was the Oklahoma City bombing.
Okay.
The year 1995 was pivotal because two groups at that moment got into rescue robotics. My group and Satoshi Tadakura's group in Japan. And what happened for us in the United States was Oklahoma City bombing, that horrible disaster. Ground robots were there, but they were the big Mondo bomb squad robots. You don't want to use robots like that. Those are too heavy. They're going to cause a secondary collapse and crush anybody who might have survived underneath. They're hard to handle. They're slow. They're like this. But at the same time, it seemed like it would be all these small robots that we were talking about, that we were thinking like Sojourner Truth was going to be much smaller. There were going to be three of them, was the original pitch to NASA. Everybody was looking at how small a robot can you make and how sturdy can it be for planetary rovers. And so those were the exact same problems that you saw at the Murrah building. So one of my grad students, John Blitch, was in the Army. He went up there because he had training in search and rescue. And he came back just totally like, no, we need to take those small robots. Instead of worrying about putting them on Mars, we need to get them into the interior of the rubble, to find people, to stay with people until they can be extracted. That's what we need to be doing with small, rugged, sturdy, extreme environment robots. And he was absolutely right. So within a year, we had the very first National Science Foundation grant to ever say the words, search and rescue robotics in there. Meanwhile, Satoshi, they had just had the Kobe earthquake, and he was at the University of Kobe at that time. and his family's fine. They're up on the big hill, the mountain overlooking the devastated city, and the secondary events of the fire from the gas leaks, and then you've got weather issues and everything's going wrong, and also looking at going, these robots that we're all talking, these small things, we got to get better. But to me, what was interesting is that the Japanese started looking, and his group started looking at big robots. We started from the small robots. So the United States has always typically been characterized by, we're going to make small robots to go into the rubble. Now, the Japanese have taken the approach that they're going to originally, now they're doing small robots, but some really nice ones. But we're going to take the big robots because we don't need to locate people. We know our population density is so high, all of our commercial buildings, there will be people there. We're just going to try to extract as fast as we can safely, right? But so we just need things to move big pieces of metal. In the United States, the FEMA teams typically, the search and rescue teams prefer, what they like to do is locate where they are and figure out how to shore up things and remove in a very different way. So two things. And then 9/11 happened, and it was sort of like, small robots win. Yay, small robots. But it was an important point to see. And now we see more of a constellation of different styles of robots for different aspects of a disaster.
And are most of these robots tethered for communications and power, or has there been advances, sort of a shift away from tethering, and that which gives you more accessibility, I presume, into the structures?
So you hit on one of the common myths, that
Okay.
tethers are bad and that you should just, back in the late 1990s, early 2000s, certainly wireless was crappy. Sometimes it's not that much better today's time. But what's happening is that you're trying to get into very, very small spaces. So now we're trying to get robots this big, preferably snaky robots. I dream about ferret robots that can be a snake and then do their little thing and then dig into the dirt and go through spaces, right? Well, so you want them small, which means you probably don't want the batteries on board. And you probably you want your communications. But then you also realize is that they're not going straight. They're not going on a nice floor in somebody's lab. They are going down and around, and we've got footage. And then from the Surfside collapse, we can now show you just how bad this looks on the inside and around. And this, it turns out having a tether also serves as a belay. So now you can, that didn't work. Pull it up. Let's try again. Go harder to the left. Turn to the left. Yeah. Okay, now I've got that way to drive the robot, get it unstuck. So Mark Masseri, for his master's thesis, went back through all the footage of the World Trade Center that we collected there from all the robots and realized, yeah, you're right. The robot's getting stuck or the tether's stuck and you're having to screw with it about once a minute. And about once a minute, you're actually using it to help the operator direct it and get it down or reset it to where it's got a better approach angle. So tether's good, tether's bad. They're just there. They're so useful to have all that weight back there. Then you can also do things like at the Crandall Canyon and Midas gold mine disasters. At the mine disasters, you can just take a break. You can just leave it there. Nothing's going to change. Take a nap, take a quick nap, clear your head, everybody get a little bit of food and water, and then start concentrating again on how we're going to get in there, search through this with this robot, direct it safely, and try to see if we can find survivors. So there's some advantages. If you're doing that with wireless, you've got a battery, so now the batteries have to be on there, and those batteries aren't going to go for 2 hours. Because you're going through the worst possible stuff. The traversability is bad. The surface compliance is bad. So you're eating up your battery power. You don't have good communication. So you're dropping stuff along the way. Yeah, that's helping. All this stuff is going on. So you've got maybe 35 minutes at best. And what happens, I have never in an actual disaster seen a responder say, yeah, we want to do wireless. They don't, we don't care. We want it to just autonomously find and then come back and tell us. They're like, no, we want to see what it's seeing.
Mhm.
Everything it sees tells maybe not me as a technical search specialist, but as the search and as the structural specialist, they're looking over the shoulder. And then you have people who are doing hazmat looking over the shoulder. And then you have like people who are doing forensics are looking over the shoulder. Everybody's looking for different things. They don't want to say, oh, apparently it got 80 feet in and then it died and we can't see what it saw. That's not a win. So everybody wants to see in real time. The only way you're going to do that is with a tether, with a communications tether. So
Interesting. Interesting. Yeah. No, I never thought of it that way, obviously. So, and I
Fukushima,
guess
they're all with that little fiber optic cable running
all
through there.
tethered. Yeah. So has there, given that making it economical becomes somewhat important, has there been sort of like a mechanical design that sort of become a standard, if you will, or at least a common approach to sending these bots into environments? Because you mentioned like the snake type robots or the different form factors are going to have maybe different have different utility and different actual deployments and applications. But is there sort of one kind of platform that's enabled to make replicating these more economical, or no? Is it
No.
all specialty?
So nobody has ground robots for rubble and for disasters. They bring in their big bomb squad robots, which are useless, or they call me and see what I got. And what we fall back on are sewage inspection pipe robots.
Mm,
And
okay.
so, and even that's kind of a small market, but it's a market. So you're taking nice hardened robots that work in water and goop. They're expecting pipes, right? Maybe gross insides a pipe. So that the idea that you're going through very heterogeneous surfaces, you're going from really muddy, slurry, pulverized concrete to now you're in carpets, shag carpet, and now you're going over Venetian blinds, and now you're going to see there. So it's a little different, but those are probably the best. And that also illustrates that the robot you use every day is the robot you use during a disaster, which is why the little inexpensive drones are so great. You have them. A fire department can afford them. A lot of fire departments, when they usually can't, just some of the firefighters just bought them themselves and donated it and solved that. But when you're talking less than $3,000, you can find everybody can pull enough money, see their way clear to get one of those. When they're $30,000, and when the drones first came out, when I first started flying them, $175,000. You know that's a huge. I mean, that's like what that's one of the fire departments was saying, yeah, that's one of those big black respirator units for every person in my department.
Wow.
Is it worth? How often are you going to use it
Right.
versus what you get? So having things that came down and that people were using, kind of having fun with or running photography, all of a sudden it's like, oh, we can use those now. We can use those for wilderness search and rescue. We can do these things. So the fact that you don't have a lot of people using ground robots for sort of civilian, commercial, consumer market means it's like they're not available. They don't exist and people do it. And one of the lessons from Fukushima is a lesson we seem determined in the nuclear industry to keep learning. It's like, okay, we have a disaster, we build robots, and then we've got robots in this locker and they are going to be great. And now it's a disaster 10 years later. How do we turn this thing on? I haven't used it. Who's used it? They quit or retired. Okay. And then sort of like, I tell people, I said, look, your phone, right? How many of you got a 10-year-old phone?
Right.
When was the last time you did an update? Probably last night, the way they do the updates. So the thing you use every day and are familiar with is more valuable. And when things are going wrong, the human factors, when things are going wrong in a disaster, you're already cognitively starting to be loaded, right? You've got physiological, psychological impact of, oh my gosh, this is life and death, literally. So little something's going on. And this is not the time you want to start learning something new.
Right.
And particularly if it's more complicated than you think. And what oddly enough, things that a couple of PhD students find easy to use, the rest of the world, not so much, not so much. So that's not something you want to inflict
Right.
on people during a disaster.
Yeah, you're touching on one of the questions, because first of all, I can imagine the impediment to wanting to invest in something that's of course $175,000 or whatever the price may be, because you want to know it works, and then you get it and then it's obsolete 5-10 years later. um, what are some, I guess you've talked about some of the technical what are some of like the operational challenges that you see these um, you know workers encountering when they first try to use these robots? Like what are some of the gotchas that they encounter?
Oh, there's so many gotchas. So we do summer and winter institutes where I'm at Texas A&M Disaster City, my favorite place on earth. All of these different collapse structures to go out and play with. And so we'll set it up where people can bring their equipment. We'll screen with the responders. We'll go through the list and say, that looks promising. Not a chance in hell. Don't even bother. This, and go through and let them come out and play. And as they do it. And so one of the first things are things like they expect to have 8 people to one run one robot. At a disaster, you're trying to get as many people out of that. They don't have, it's hard enough as it is to support the minimum number of people. So I tell people, you want to train me and my team, we are responders, and then you tell us how to use the robot beforehand so we can insert it, because we're not just going to take people who've never been in a disaster. I get engineers, I had a group of engineers show up. I mean, it was like a Silicon Bro thing in flip-flops for Hurricane Harvey to use in the field. And it's like, oh dear God, no. I mean, we're not doing the cute shorts and sandals. But it's like, dude, we're not surfing. We're not surfing. Have you ever seen a picture of a disaster? You notice nobody looks like that for a reason.
Right.
And I gave you a list of what to wear, kind of thing. So, and then it gets into the ethics. Is that we embedded a couple of times with my colleagues in psychology and human factors, some of their one or two of their students, and it's like I can't take them to the field. I mean, in one case it was a volcano. First off, I've never worked with them, so these people don't look like no background like camping or hiking. So there's no expectations that their default skills are going to be really up to it, have thought to it. A very dangerous things where we're literally next to lava that may break and start running like in the movies, and the cars are facing out and everybody's kind of keeping an eye on it, and you've got gas,
Yeah.
sulfur dioxide coming out. I can't just put somebody in there without knowing their health, their training, and that's not fair to them. Something bad could happen. And so it's not only is it unethical for me, then you get things like during the Great Eastern Japan earthquake, the Tohoku earthquake and tsunami, we were called over. We had a formal invitation from 2 cities in Japan the next day. Turned out it happened the day that all the Japanese researchers in rescue robotics were here at Texas A&M doing one of those exercises at Disaster City, and United out of Houston was the only still flying into Tokyo. So they managed to make it back. So they called us in. Well, before we could get through the National Science Foundation, we asked to please pay for this because of the science. And they're setting everything up. But within 3 days, about when we're fixing to head out the door, they put a hold on it because so many civil engineers from all over the world had shown up into Japan to take pictures. And Japan was like, look, you're overloading us. We don't have enough food and water and electricity. We have brownouts, rolling brownouts in Tokyo. We don't have power because Fukushima. We've got a nuclear thing going, Chernobyl. We can't be responsible for everyone. And by the way, don't you think we have civil engineers too? And we are really famous for photography. So it's kind of insulting that all these civil engineers are coming over taking food and water and shelter and fuel from the locals who have all been displaced and kind of saying, oh, you're not smart enough to take pictures of your collapsed building. And so please don't send any more over with NSF money. And so then I went and see, but no, we have an invitation. We're not those kind of disaster tourists, which is
Yeah.
what we call that. And then my Japanese colleagues were like, no, 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 no. They're really supposed to come. We want them. And it still took 2 weeks. But that gives
Wow.
you an idea. When we saw that at Harvey, a group of people from Wisconsin announced that they're coming down to fly drones at Hurricane Harvey. Why? Because people needed them. I don't know what people. Uh, the people that need them are the incident commanders, and they have very strict rules and protocols because of all of these logistics and accountability and what they can handle and control and what they want to see. So it gets interesting.
Yeah. No, that's it. I mean, I think I heard of, I can't remember which flood in the US where there were some, I thought there were some automated like boats or something going out, or they small vessels that they were sending out to search for and find people as well, right? Was that, am I correct in that, recalling that, or am I sort of imagining something here?
Certainly not with any of ours. I mean, we did try to use the Emily series at at Harvey, but one of the problems with Hurricane Harvey is you've got all these non-navigable rivers and creeks, those
Hmm.
bayous. Everything's draining down into Houston. You don't know how deep it is. You can see how high the water to the banks, but you don't really know what the carrying capacity is. Nobody's ever mapped it out. And so some of these Emily's that we use for lifeguards, it's a lifeguard assistant robot. Think of it a robot with a really big life jacket on it that 5 people can hang on to, or it can zoom out instead of doing one of those taking a shotgun and running a rope to you. It just runs out to you and you can hold and grab it a little more sanely. But anyway, they come with sonar. There's one that comes with sonar and you can use that to try to estimate. But the currents were too strong. It was just too much
Yeah.
of a mess. So we didn't, I'm not aware of it for flooding. Certainly not our group, but it's something that has been looked at.
Interesting. So I imagine also I mean, you touched on it, the kind of the human robot interaction, and also the interfaces that one needs to have to make it easy to use these disaster robots. What are some of the, and human robot interaction has been another area of interest of yours, I know. And so, what are some of the dynamics, I guess, with human robot interaction in these kind of high stress environments? Like,
There's a lot. I think probably the one that is the most surprising, and I think is having the results are having a bit of an impact, a good impact. And I'm very proud of his work that we've done with Camille Perez and Ranjana Mehta and occupational health and safety and industrial engineering. So for years, I mean, literally starting with at the World Trade Center, as we're documenting, we're showing that we got about 3 hours of continuous sleep for I think a total of about 8 hours over the first 52 hours. So clearly, you're a tad stressed little puppy trying to work something through a mediated environment and in an adversarial environment. Okay, so it's extreme environment. So you've got all that, and you're tired as heck. Kind of know that's not a good thing, right? Even on a good day, working through mediated, turns out running robots is a little bit like running a fever, a low grade fever. You're just a little off your game. Well, I kept telling them about this, and they said, sounds totally reasonable based on process safety, what you see on the big oil rigs and things like that. Uh, and so they started doing studies with us, and what they found, they said, holy cow, you're not kidding, Robin. You guys are all showing up with fatigue levels of about 0.05% alcohol equivalent, which is legally drunk. And for flying, it's a 0.04%. So the fatigue levels after one day shooting up. And let's say you do get some sleep. At Hurricane Michael, Florida, the state of Florida, Florida State University's team was running it for the state of Florida, and David Merrick had set up where we actually had a routine sleep schedule. So that's as good as you're going to get. You've got air conditioning and a cot, yay team, and it bounces back with a night's sleep, but not all the way. And so what you're doing is, okay, really tired, not really tired, and it's just keeping going through, and it just accumulates. And they were able to replicate that. Hurricane Michael, we saw it at Harvey, at Michael, and at the Kilauea volcanic eruption. And then we've replicated that. We were able to do a full-scale study of that with responders who were at Ian and seeing the exact same things. So what was nice is that, well, first off, that gets back to that. Oh, these are just little toys and they're consumers, so they're easy to use. It's like, nah, actually, we're talking, you kind of got to worry about them the same way you do helicopters. I mean, sure, probably can't do as much damage. I mean, never say never, but you're going to have more accidents. You're going to have more problems if you don't pay attention to your crew fatigue and how you're doing your resource management that way. So you're going to have to think about it more like that. So you can't just make people work 24/7, literally, and put them on constant call. So if you're tasking them, you've got to think about that. If you're organizing the team and you think you're going to have a night calls, then you've got to put some people in reserve. And that's always a fun choice because I want to fly now. I want to fly. Put me in, coach, kind of thing. So you got to organize that. So I brought it up to the NFPA, National Fire Protection Agency, who are doing the 2400 standards on aerial vehicles. And it was before we had published. And I said, well, we're actually seeing this, but we don't have publications. Literally, everybody's head swiveled to me. And they say, as soon as you can get us anything that we can cite, we thought we were seeing that too, but we need a piece of paper from a scientist basically so that we can change the way we do our crew management and say how many people are staffed for this and what does it take to do that. Because otherwise you just got people saying, well, you should be able to just fly and then take a nap and you'll be fine, type of thing.
Yeah. Now is that for purely like teleoperated robots, or is there some hybrid or even not full autonomy, but hybrid autonomy layered into it?
This is for drones. And some of the missions, and this turned out to work we saw the same impacts with whether you were doing first person view, because your first initial missions are usually click, bad. Okay, picture of that. If it's really bad, somebody's calling it in, right? Mm-hmm. And then sending one or two pictures because your internet's not up. You're not really got a great way for them to see anything anyway. And nobody's going to watch 20 minutes of video. Then later on, after a couple of 3 days, you start going into this mode of doing mapping. And that's one of those, you press, turn the below the map, press the button, takes off, click, comes back, turn it off, head on. So we didn't see it particularly peak with one particular type of mission. What we were seeing, it's time. It's the nature of the beast. Mm-hmm. And it's what they call off normal. You've gone to this, even though you've done this situation, you've flown these missions time and time again, it's off normal. You're in a different place. You're off schedule. You're at a disaster, and then now you've got all these other cognitive fatigue, and it's just all layering up on you, and so you got to be careful. So,
yeah.
And you're seeing some of those findings as well, so I'm very proud.
I guess and maybe this is more relevant to I don't know, ground robotics, but is there been any sort of study or any experience that you've had with the trade-off between just littering the environment with small, low cost, like a swarm of sort of search and rescue or surveillance robots, and or fewer, maybe more expensive, robots with more human intervention and control.
So I'm going to hit that from two different ways, and one is the swarmy way, and I'm going to poke holes at that, and then I'm going to also talk about the trade-offs. So the answer is kind of no, yes. So the idea right after Harvey, I saw a bunch of people say, "Oh, drones are cheap. We're going to create a system that's going to launch 100 robots. They'll cover an entire county. Click, 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 map everything, come back. You'll get this done in 4 hours, and then everybody will have everything they need." Okay, good for you. Yes, you could do that theoretically. You're, of course, beyond line of sight. Okay, now I can think about okay, so you're going to launch 100 small, inexpensive robots for a county in Texas. It's going to take that all of its battery to get to one end. So you're not going to launch them all from the same spot. Okay, well, how the hell are you getting to that other spot on the other side of the county anytime soon?
Right.
You actually need to pop up the drones to figure out what roads are not flooded. Okay, so all right, great there. All right, so you've got 100 things that are going click, click, click all over the place, and you're going to come back, and now you've got 120 gigabytes. You got to drive somewhere. You got to get it plugged in. Uploading 120 gigabytes to be processed. And by the way, for the first couple of days, nobody cares. What they're looking at, they know where the low spots are. They know the vulnerable populations. They have an idea. So what they're looking at using the drones for are spotlights. Yeah. Get over there quick, confirm what it is. That neighborhood's not bad. Those are both built in the 60s with screws for the. We don't have to worry about those 5 other neighborhoods over the other side of the county. All right, here. Oh, that's even worse. Something the drainage isn't right. Something. Go fly up that way and see if you can figure out why it's all backed up. So they're doing that kind of very rapid recon, very rapid needs assessment. Then they start doing it. So now you've got 100 robots going out, taking up all the airspace. By the way, I can't tell you how much the life flight people in helicopters and the military people love little drones flying around.
Yeah.
Not so much. So, and it doesn't matter about remote ID and stuff because you don't really know where you're going, kind of the rough area, but they got to go and they're taking off, not doing, they're going, I got somebody dying, I need to go this way. So it's on you, the drone operator, to look for the safety. And then you got people at Michael, we're sitting there flying. It's an evacuated area. There's still people privately flying, trying to get a little heads up on what their property damage is to kind of be first in to start getting some estimates. Right? Can't blame them there. They weren't supposed to be in there. But we also have the news media now flying drones. And we almost had a collision with one of their drones. So it's like, but we're the state of Florida. So it's not as easy as just putting up 100. What a better solution is, and so I'm backing into this kind of the cool thing, is if you've got satellite data, that's the way to cover a large area. Or if you've got mid-altitude regular, like civilian air patrol or other NOAA, is being able to grab those sources and start figuring out not as good a resolution, but then if you don't see something you're not sure of, that's a great place. How do we get a drone team over there to see that? And remember, don't look around. We had one of the disasters we were at. All of the helicopters, the regular helicopters, the FAA had given a TFR to say stay out, and only a few were allowed in, and they were supposed to be monitoring a pipeline, except for here we are flying along the beach, no pipelines anywhere near, and here, because all the beachfront damage and the storm surge and the road that was taken out along the beach, trying to document that, here comes a helicopter, and the guy, with his cell phone is filming, right? The door is open. It's pretty clear. They've kind of like not where they're supposed to be. And so you just can't pre-program everything or assume. And I'm pretty sure that route wasn't on their flight plan. Okay, so so I think we've got a lot going with the remote IDs and stuff, but at the end of the day, you've just got to have enough situation awareness of what's going on and be aware of that. So these swarming ideas, lots of cheap ones, don't make as much sense for the airspace because it's a shared resource.
Right, right. And is there I mean, there any sort of combined use of the ground with the air, have the ground vehicles sort of take the air robots to a location and launch them from there, and any sort of cooperation between ground and air based mobile autonomy?
We've certainly seen a lot of demos, and
Yeah,
I've done those, and there's been funding on that. Not as much practical because wherever you would be taking it, your SUV, your super duper SUV would get there
yeah.
as well as the ground robots. So what's the deal? I mean, we did see in in and what was kind of like, oh, well, that's kind of Ewok technology, where one of the bomb squad, Surfside, one of the bomb squad robots was holding up a repeater to help one of the aerial vehicles. That particular model is not pretty sensitive to wireless dropout and go into the parking garage. So after the Surfside collapse, you've still got part of the building standing. They're trying to figure out who was there, right? So one way to do that is to go look at all the license plates and try to figure out. I mean, it happened at 1:30 in the morning, so you're not expecting anybody to be in there, but it'd be nice to be able to try to back off how many residents there really were, particularly in the area that totally collapsed.
Hmm.
So they would say that. So you can try to send a ground robot in, but parking garages are bad to navigate in anyway, and then it's partially collapsed. You don't want to send a person in because it's pretty unstable. So they were sending drones in to go do that.
It's fascinating. I mean, there's just so much to talk about with respect to disaster robotics, and also maybe um, I think of the I mean, is there any utility in sort of bringing these into situations where you can prevent disasters or situations? And I was recently talking to uh, a colleague of your who was looking at bringing robots into, or had the idea, I guess, or was pursuing the idea of bringing robotics into schools for with non-lethal but also surveillance type mechanisms to help mitigate, if possible, school shootings, which is a you know just a whole other kind of tragedy and disaster. And I thought there were some interesting uh, concepts and applications there, but there was sort of the same theme. How do you make it economical? These things have to work. They have to work well. And what are they going to do? Right. Okay.
Yeah, a real can of worms. And you had earlier had asked me, do I call it rescue robotics or disaster robotics? Well, I call it disaster robotics because it's not just that immediate rapid needs, saving lives, figuring out what's going on, mitigation stage. It's both the prevention and preparedness, trying to be prepared or mitigate risk and vulnerability, as well as how can robots be used for the long-term economic recovery. And all of those phases are very, very important. And we've been trying to push more that now that the particularly with drones being cheap and accessible, since they're really consumer products now, is for departments to start using that to do things like start mapping out their floodplains,
Hmm.
start updating, because even wealthy counties will often only get their counties mapped like once every 7 years. So theoretically, you're supposed to have it done like every couple of years for their floodplains and that. But now you can get some rough estimates at least. You can get more expensive ones, but still less than it takes to get some of these manned crewed aerial assets. You can start putting things like LiDAR on and really getting a little bit more accurate of your digital elevation maps. Same thing starting to look like, what can you do with these robot sonar boats? Can you get back up and start estimating more of what your actual carrying capacity is of those bayous? Are you're just kind of making, you've got a little line on the map and you're estimating what the width and the depth are. Now, can we tighten that up for you a little bit? And so that can really be a game changer. And that's what we'd like to see more and more of that. We did a study on the Navasota River. And one of the things, it was just kind of accidental, we're flying along the river and flying over a couple of bridges. And people have been complaining about the property being flooded. And, there were all these hydraulic models. But you just looked over and both bridges were just covered with debris from trees that had fallen over the years. And it just kind of built up, it kind of like made their own little dams. And that, since they're in the middle of really nowhere, literally, no one had really noticed or thought, or state had never, county officials didn't realize, and then it's pretty easy. You look at it and go, well, that could be it may not be the problem, but it's definitely a problem. We need to get somebody in there to clean that out before, the rainy season.
Yeah.
So we're trying to do more of that kind of stuff and encourage departments and not just think of this as a fire rescue or a public safety, but as a true emergency management, a true public works sort of thing.
Interesting. And now, in terms of bringing this into education, you've got AI robotics and disaster robotics. Your books that do you I guess how do you? What are some like the insights that you bring into your work into those books, and how is that being used in sort of education right now? Maybe in your own courses and other lessons taught throughout the country and world.
Well, in part of my life, I'm just your standard academic professor who does artificial intelligence for robotics. And so my textbook is very AI robotics. My disaster robotics book is, here it is. And I'm not just telling you how to do things, I'm telling you why. It's very evidence based. Okay, here we're going to analyze everything, not just what I've been at, everything I can find from ever until when it was published in 2013. I'm working on a new edition that's focusing on drones. So how do you analyze it? How do you measure? What are the things you really should be looking for? What are the human factors? What are the mechanical? How do each of the subsystems fail? How would you formally characterize the environments? And so that bleeds over into my coursework for academics, because it's how do you test and evaluate? How do you take what's called a formative domain, a domain where nobody knows exactly how they're going to be using this or why. They know it's kind of important. And so you're having to build something to very clearly unspecified. That was an oxymoron. Things that no one really knows. They say they want something. Who knows what they really want? But you got to get in there and try, and you've got to rapidly update. What does that mean to us as robotics? And robotics is still largely formative as a whole, right? We don't know how robots are going to be used. We've had some great success with things like Roomba and warehouse robots, but we need to, how do we think about the design? But I also am fortunate that with David Merrick and Justin Adams over the years, and then some of my grad students earlier on when I was at the University of South Florida, Jenny Burke in particular, we developed courses and we still offer them to train responders. And we have one that's oriented for emergency managers. It's like, no, you're not going to be the one driving it, but you need to know, here's what it can do, and you've got the enthusiastic people. Oh, I can do everything. All right, here's what everybody else has been doing with them. Here's what it's going to cost. You need to, anytime you buy one, you need to buy three. Okay. We say 1 is none, 2 is 1, and 3 makes a decent system, because it turns out, like with little drones, and we've seen it with ground robots, we've seen it with Emily, if you have one, it'll break or something, and you need to immediately put another one in service, and then you probably want to wind up using the dead one as parts, and so now you've got 2 and a parts robot. You can see how this goes.
Yeah.
Which also, notice what that means. Now you've gone from having, oh, I can fit my robot in the back of an SUV. I was like, yeah, well, can you fit 3 of them in the back of an SUV? Oh, and by the way, if you've got a drone and you can't fit 3 of them or even 1 of them in the back of an SUV, how are you going to charge the batteries? Because we're going to send you out for 12 hours and there's not going to be any electricity. So If you can't charge those batteries off of there, where are you putting the generator? Did you bring your own generator? Where are we getting the gas after the second day, after you run through it? Because we're all going to be short of gas, that our diesel. And then it's, oh, and are you going to pass out because you've got gas fumes in your SUV? All right, we're going to strap it on the top. So the logistics, we really have to push on the logistics with teams coming in that have never done it before. And that's why we typically don't bring in groups that have never, even if they're, from agencies that do it. It's, if you've never been to a disaster, you may not know what an austere environment is.
Yeah. Now with AI and robotics, is there, as you mentioned, there's been many there've been a few AI winters. I don't know how many, but now the generative AI or LLMs and GPT AI, whatever you want to refer to it as, is all the rage. um, Working with many engineers, they gravitate towards the latest, greatest, shiny object, and it is it's a great tool. It's certainly very interesting. Are there any advantages being conferred to the world of disaster robotics from this kind of new generative AI methodology or is it still
I think
brewing?
the classic generative AI, the Chat GPT stuff, I'm not so clear on that one. Okay, certainly we're the idea that you could automate how you have to annotate some of the how you have to, for instance, when you take images, you'll often have to do a PowerPoint slide to say, here's what we found, here's this, here's what this means, that they can pass up the line to people who aren't there. So that can be a real pain in the tail to do. So having a generative AI do it. The bigger win for us and the more thing is that computer vision, machine learning, being able to do, we've seen good work with satellites for the damage assessment. It turns out with the drones, it should be better, right? Because you've got higher resolution stuff. But it turns out nobody has annotated data sets. So we've been doing that. One of my grad students, Tom Mancini and Priya Pirali, are fixing to announce the largest data set, 10 disasters, 10 times as much area, way more pixels, and annotated instead of just saying what we've been saying for years is that, hey, Craystar has all these images, you can have them. And he's like, yes, but somebody's going to annotate them. One of the graduate students at University of Maryland, it took him 2 years to get the flood data from Hurricane Michael annotated. So what we did is got 4 high schools, 151 students, high school students for STEM, in exchange for a nice lecture on computer vision, machine learning, to annotate it for us. And they thought it was a fun game, and and these are buildings, right, and roads. There's nothing untoward for them to see. No. Personally identifiable
Sure.
information. So it's pretty straightforward. And we have a couple that we are pretty sure spent the rest of that month not paying attention in classes, and their other classes annotating. So we feel kind of bad about that. But huge amount of data that got annotated.
Yeah.
And so what's nice about that is that now becomes, it's so rich. It means that you both have the way to develop your computer vision machine learning models on very many attributes of a disaster. You want to look at building damage? Do you want to look at debris? Do you want to look at roads? Everybody forgets roads. Yes, the buildings are down. How am I going to get resources there? Can you tell me what roads are open? Or am I going to have to get there, take 3 hours to get there, like at Hurricane Michael, and then discover I need to go another 4 to go around to come the other side because one of the bridges is washed out and there is no way, you will not be driving through the newly opened channel that's formed there. And so that's part of what we do. So now you'll have so many things to look at from there. So I think that's one of the things I think we'll see more, computer vision, machine learning. Now that said, I've seen some really sketchy stuff, this kind of, look what I did, I declare victory, in there. But I think that's just part of a new field and everybody trying to
Sure.
get
Sure.
there.
Yeah. I mean, I mean, there are many applications. I guess I thought maybe there might be some way to help sort of bridge the gap with the human robot interaction question, because it's a very natural way to kind of ask questions and sort of have a dialogue. And I just thought maybe there might be something there brewing.
Yeah. Although with the
So
chat GPT, we do have a student, and there has been a nice paper by another group who I forget where they're from, uh, on chat GPT looking at stuff like, normally when you get your damage assessments and stuff, you get images with little areas in yellow, little polygons all over the place, and what seems like 1,000 layers on your maps, and then some sort of spreadsheet. And so having ChatGPT put that into it, 145 homes were totally destroyed, some of this and this. And of the 145, 100 were in a neighborhood that has an income below blah, 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 that sort of thing. And so really doing that stuff is pretty nice.
yeah, interesting. Well, switching gears just a minute here, I guess there's two books on the intersection of robotics and science fiction. So I think just can you talk about how you came to that, and what is that intersection between this field that we're in, robotics, and then this wonderful world of science fiction that we all adore.
Yeah. So, I grew up reading science fiction, love science fiction. So here I am. Let's fast forward. I'm trying to teach robotics. It's 1992, and robots are a thing, but there's not that many of them. You can probably, for ground robots, we don't have aerial robots yet, uh, and marine robots. So, I mean, there's maybe you can count on the fingers of both hands. Well, it's pretty hard to give compelling examples of robots that work, and particularly ones that are trying to use AI, because the robots themselves aren't mechanically working, and we don't have AI. Even though we can see it coming, we've not put it on a robot, right? They're not sophisticated enough. So I just gave up and I started saying, okay, we're going to use this story. We'll take this Asimov story. We'll take this Vernoy Vinci story. We'll take this. Let's walk through this. And I also started doing on Saturday nights, we do a science fiction double feature of two robot movies. We'd start off with the classics, Metropolis, and then Forbidden Planet. And you start seeing, okay, look what shifted. Here's what the expectations are about robots. Here's what they're thinking. And then we start going into the other ones, and talking about what's real and what's not real. What would you do there? Would you really build a robot that did like that? Why or why not? And those different things. And so I've always taught. I've always kind of had that. And so I wrote up all those the core stories and got the rights to them, which was really the hardest part to pull those stories together as a companion to my introduction to AI robotics. So if you see, it's kind of like trying to explain like chapters 2 through 4 are captured in one of the iRobot stories from iRobot, Runaround by Asimov. It just nails it. Okay, there's another Asimov story that's really the best story I've ever read on teleoperation, where you can take the checklist. There's kind of a checklist for when you should use teleoperation and when you're gonna maybe that's not a great. And it's just the characters, without knowing it, without Asimov really knowing it, went through that basically that checklist in deciding to come up with the solution they came up with. And so it was really fun. And so then I kept on with it and began working, doing little articles every now and then for Science Robotics, the journal. And they do things like, hey, we have a special issue on cyborgs. What does science fiction say about cyborgs? In 1,000 words, go sum up that. So that would be kind of like my little hobby assignment. And so the cyborgs to me was fascinating as I started to go back looking through the literature. Do you know who wrote the first cyborg story, as best we can tell?
I'm familiar with there was a Russian. Is this the was this the gentleman who came up with the term robot?
No,
No.
he wasn't looking at cyborgs. So
Okay.
the first cyborg was actually a story by Edgar Allan Poe.
Oh, okay. I did
The
not know
man
that.
who is all you, well, who did? I mean, what? How fun is that to be able to go look stuff like that up and discover? And that idea that the cyborgs, it made sense, right? He's coming out, they are coming off of a series of wars, in real life. And so Poe is writing a story about, it starts out like the typical creepy Poe story. This famous general has gone missing. And finally, this young guy says, I'm going to find him no matter what the cost. And he tracks him down and finds him at this old house. The last he's seen of this big old plantation style house. And he goes in and it's very dark and creepy. And there's just a pile in this sort of bedroom thing. And he says to himself, I'll never find this guy. He must be dead. And a voice from the pile says, oh, my dear, you're here. Oh, sorry. I didn't know anybody was here. And he starts assembling himself for he had lost an arm in the Civil War. He had lost an eye at this battle. He had done this, so all of his famous medals also represented a battle in which he lost a part of him. And as he's going, he's talking about, oh, so and so makes the best legs, and so does the best lenses for eyes and things. And, what? So it kind of made sense given the wars, the advent of the
Yeah.
mini ball, the damage, and you're moving beyond just a wooden hook, that somebody would have noticed that and start extrapolating to the future. I just hadn't thought it was Edgar Allan Poe.
Interesting. Interesting. I'll have to look that one up. He went to the University of Virginia right down the road from me here, so I should
And
be a
that
little.
movie, was it The Thin Blue Eye or something? That was Christian Bale, and it was on Netflix for a while. It's actually pretty good, and it's sort of a setup where because Poe was at West Point for a short period of time, and so Christian Bale's character is called in to investigate a crime on he's a former army guy, and so they trust him to come in and figure it out. And he gets with this cadet Edgar Allan Poe, who's kind of a doofusy guy, but watching, and you're seeing all these foreshadowings of what would later become the Telltale Heart and the
Hmm.
Raven and all those other things. So it's kind of good.
Interesting. Do you see like when I kind of grew up in the 70s, 80s, 90s, the Americans seem to be and American sort of movies and such seem to be fascinated with robots that are going to do humans harm. And I've seen it just seems that way. And whereas maybe in other cultures, I guess like in Japan, some of the and the robots were a little bit more helpful. And I wonder how that shapes American perception of. I mean, it's not black and white like that, obviously, but we have R2D2, of course,
And Wall-E, right?
and Wally,
Come on.
but 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 we also have the Terminator and a Blade Runner and all these stories that paint a very bleak picture. But do you think this like how has science fiction sort of shaped public perception, not just in the United States but in other countries about robotics, and maybe negatively or positively?
I've read papers on that. I mean, there's certainly scientists, sociologists who study that and say, and there was one that went through the cultural, that Japanese do and tend to, and they blame Astro Boy, that they watch as a cartoon, really happy robots, and then stuff with there's there's also a difference. How much do you ascribe to things you take seriously? So, I mean, who among us really believes that we're going to be running giant mechas to thwack aliens from underwater like we saw in Pacific Rim, right? I mean, and to do that, you need to be telepathic to control the robot because apparently we have no clue of how to design controls. So, I mean, so yes, there's lots of action and fighting. Is that really science fiction that informs? Whereas you get the impact of something like 2001: A Space Odyssey, and that was so plausible, and it still looks plausible, right? And so, what's the impact of those kind of movies on that? as well. So so when is a movie that versus just straight up entertainment? When does it become that? And I think that's much harder. And I think the papers I've read have had a harder time trying to make that distinction from stuff that we all know is just dumb and fun, and things that really, oh, what if? And I think
Right.
that's one of the fun things with the first couple of seasons of HBO Westworld, right? In the very first movie, Westworld had a lot of interesting implications about that.
Right. Believability affects really how seriously people take it. I mean, but then you see, but you can certainly imagine um, robotics being put to um, you know harmful use, right? Maybe in certain. I mean, robotics can be useful for DoD applications for force protection and what have you. But on the flip side, there's going to be robotics that can do real damage, right, to human beings, and at what scale? I guess
Well,
that's
the drones that we've seen for the past decade, and certainly see right now in the Ukraine Russian
mhm.
war, and that everybody saw it coming. The cyber attacks on the drones, and who's doing this, and that, and how big do you
Right.
have to be, and how do I defend against something that if I don't have a radio signal because I've just pre-programmed with GPS, what am I going to do? Take out everybody's GPS? I'll take out everything we use it for, right? So it's a very complex problem. Just some of the technology is very ubiquitous. But
Yeah.
thinking about Westworld, is that the original one with Yul Brynner, and was was very much that the man in black, who at that time was called the gunslinger, that robot. The terrifying thing was it was a machine. It was just going to keep doing that shooting at Richard Benjamin until he got him. I mean, he was just ruthless automation. And that was very much a reflection. Crichton was doing a nice reflection of the factory automation at the time. Now we have HBO Westworld, where we don't have that level of automation. In fact, what if we've created something that is intelligent and should be treated as a person, but we are unethically uh,
Right.
treating it and subjecting it to just every bad thing you can think of? Yeah.
Yeah, it's a great series. I've seen, and it's been a long while since I saw the first one. So yet another reference that I'll put here for people to go check out. Um, so just a couple last questions, if you'll indulge me. I guess your perspective really on the future of AI and robotics, and your projections about how things are going to evolve um, from where we are now and today.
I think my projections are totally worthless. I mean, at 9/11, I just, I was proudly telling everybody in 10 years we'll see these ground robots everywhere. And there I am at Surfside and no robots like them there, even though they're useful. And there's just so many factors
Yeah.
that do with the future. I do know that it's the future. It never looks like what we expect, right? It's the robots, the very subtle uses that can have the big impacts, like the making the commercial small drones. That was the game changer, not the big serious drones and things. One thing that I think in the past few years that I've really gone to like a lot about projections about the future is that Gardner hype cycle. Have you ever seen that?
Oh yeah.
And so I really like that. I show it to my class saying, so everything that, gets a little hype, and, the hype, blah, 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 is here. And then it settles down. And what you really get over here is about half of what everybody was outrageously claiming. There was meat there. Takes a while to find out what the meat and actually commercialize that meat versus overdone it. And there was the thing in the Wall Street Journal today saying, people are buying the Microsoft AI stuff and saying, well, why did they buy this? It's like it works, but it's not as much as they promise. It's like, yeah, we've never seen that with any product before ever. Yeah. Software, we're going to suddenly believe those people anyway. So I think the good thing about the future is that we are seeing a lot of wonderfully wild and not clear to me that we can achieve ideas, but that means about half of them we will, and that good things will happen because of that. And just hope a lot of things get added to the emergency response domain. Uh, it's an often neglected area, and it's so important.
Yeah, no, absolutely. And it's such a great application. I mean, what advice would you give to students and just professionals in the field who want to get into just maybe robotics in general, but also disaster robotics, maybe specifically, because it's such a fascinating field.
Well, students often ask me about, well, oh, I guess I must go to the top robotics school, and what's the right major for robotics? It's like, I don't know. What do you want to do with it? If you want to do AI, you're going to be primarily that's going to come out of a computer science background. So you're certainly going to have more advantages if you try to hit it from, say, a mechanical engineering department, which will be more on the physicality of the robot. But these aren't mutually exclusive. That it's not just being good at one thing. And one of in my career, being at 9/11 and having had a couple of classes in anthropology, which I took just because they would be kind of fun, were so helpful because of the ethnography.
Hmm.
Quick, take notes in a structured way, look for these types of human factors problems, look at that. If I had gone the straight path that one of my dear colleagues, brilliant researcher, his path was very focused and very narrow. Mine was wandering all over the path. We both did, grew up and did pretty well. So that's the same thing. The lesson for students: you find your own way. Uh, I personally recommend go broad. Don't become the world's best person at Python programming. What other programming languages do you do? What do you do? I mean, Lisp is going to the pursuit. Those types of languages will be coming back because they're so good for AI. They so
Hmm.
reflect the way we think versus how I have to get it into a computer. And so those missions. So you bring everything to the table, and that's what makes you you, and that's what makes you be able to contribute. That is different than how somebody else can contribute. And if we all throw in our best skills, then the good stuff will emerge. So that's what I try to tell people.
Excellent advice. I mean, if, as you know, the popular story of Steve Jobs didn't take that calligraphy class, we would just have ugly fonts. We wouldn't have what we have today. Is the story anyway? But no, the intersection of different disciplines and all that is definitely an anthropology, psychology, neuroscience, all these things, and how they affect your work is is so critical and definitely and oddly enough, some of our best engineers are musicians, and I don't know why that is.
There's been studies that correlate that with spatial reasoning as
Yeah.
well. And so those two get together. I remember when I worked as a student assistant in the College of Engineering in the dean's office at Georgia Tech, and there were schools that didn't have, it was right when the SAT was becoming popular, but not everybody did it. And I remember the associate dean said, let me see their high school transcript and if they took music, if they've taken any music or languages and were good at them. Because music correlates with mathematical ability pretty strongly. And languages, if you're taking a language in rural Georgia or Alabama and doing well at it, you are clearly good at self-discipline, learning things that are a little more abstract that aren't in your face, because everybody's speaking French for some reason in your town, that sort of thing. And so they'll have the discipline to get through the tough times. All those prereq courses are god awful. I thought, boy, I had a tough time getting through them. But anyway, he would look at that. So I think
Yeah.
there's something to it. But I think that building those all the things you have, bring to the table, and don't be ashamed of all the cool stuff that isn't classical math or programming or stuff.
Excellent advice. And yeah, I my own self later in life, I picked up the guitar and started learning how to play it for the first time just a year and a half ago. I'm not ready to go on tour, but it definitely is, it's cathartic, and I'm starting to see the correlation between what you just said, the sort of the mathematics of it, the pattern recognition, and the relationship to kind of what we do in computer science, at least. Um, I guess just looking ahead, what are some of your upcoming projects and focus areas, not just in research, but in how you're innovating and your writing and just your general sort of activities in the field?
Well, a lot of it's keep on keeping on. I'm still behind in getting my book out on drones, on documenting how drones have been used for disasters and what we've learned from that, and how to train from that, and what all those ramifications are. There's just so much. It's part of, it's pulling it all together. And so that's very exciting. The work that we're doing in computer vision and machine learning with my wonderful grad students. The things like the fatigue, that as you see how to insert, we're also doing some of our human factors and HRI work is showing the drones aren't falling out of the sky anymore. The errors aren't actually why we're flying, they're before and after. That's where the mistakes are coming in that prevent the right data getting to the right person in time for them to make a really helpful decision for the response. So how do you cut those down? And that's been fascinating. We look to keep doing that as well. I do hope to go back and do a little bit more professional training. I think we've got another round of up and comers to show, hey, look, here's some things that we've looked. Let's take the past 5 years. We've seen a lot of use of drones, and now we've got enough to tell you here are some true best practices, and here's some things you want to do to kick the tires. And then on that, and as a straight AI roboticist, as a straight up traditional, that whole testing evaluation is trying to how do you categorize these very odd extreme environments in a way that's useful to predict whether a sensor or a locomotion effector, wheels or legs will work in that environment, or even what size. What do you need? How can you do that, both to test but to predict what to build? And so from a theoretical point, I've been working on that for years. So we need to see some results there.
Well, it's been fascinating. Thank you so much for taking the time here today. From disaster robotics to human robot interaction to really the intersection of robotics and science fiction, it's all fascinating, and you've got so many great books out there. And like I said in the very beginning, your book was one of the things that brought me from doing what I was doing at the time, very interested in robotics, and really motivated me personally to just sort of do exactly what you said, just dive right in and start exploring and wandering, discovering what your strengths are. And so thank you for everything you do, and I really appreciate you and what you've and you taking the time to be here today. Thank you so much, Robin.
Thank you, Paul, and thank you for sharing that. I appreciate it.
Thank you. I hope you enjoyed the show Driven with me, Paul Perrone, your host. Don't forget to check us out at driven.show on the web, and give us a thumbs up or subscribe here if you like the show. Thank you for listening in. See you soon.